Welcome to another webcast brought to you by Digital Dimensions. I'll be your host today, Joseph Richter, and today we're going to talk about tolerance in SOLIDWORKS with the DimXpert and TolAnalyst. The topics that we're going to cover today will be, in general, what is GD&T? We'll talk about the GD&T elements. I'll introduce you to the DimXpert, and when using the DimXpert, we take a look at the different part types that we can set up, the different tolerance types that are available. We'll talk about the DimXpert settings and then the features that the DimXpert supports. Then I'll talk about what tolerance stackup analysis is. I will introduce you to the TolAnalyst, and then we'll talk about the main features of the TolAnalyst. And of course, we'll be demonstrating this as well. Okay, what is GD&T? Well, it's a way of communicating dimensional and tolerance requirements for your part. Now, I know when I was in the industry that a few shops, when they would see that on a print, they would just, start adding the dollar signs there and then try to be really close. The problem with that is that isn't necessarily what GD&T is. GD&T actually allows more imperfections. Your tolerance zones become larger when you use GD&T, these symbols. So again, just because you see it on a print, you automatically assume that it's holding the parts tighter is not necessarily the case. I would point out that GD&T practices are governed by standards manuals put out by ASME, and the website here is, I'm going to go ahead and pull it up really quick. Okay, you can check this out. It's asme.org/codes. If you don't have a copy of this at your shop, I highly recommend getting a hold of one. It is how all of our drawings are interpreted, and more importantly, how to apply GD&T. Now, this particular webcast, I'm going to show you how to use the DimXpert and the TolAnalyst tools in SOLIDWORKS. I am not, however, going to show you how to apply the standard because that requires proper training, and that's not what the target for this particular webcast is. Again, I'm going to show you how to use the tool, and then if you want to apply it correctly, then I highly recommend looking into a course. One of the ones that I recommend here is allamericantraining.com. That is all-americantraining.com. And for those of you who are at SOLIDWORKS World 2008 in San Diego, Glenn Stewart presented the best technical session that I attended there. Well, here he does online training for learning the standard. So again, if you want to get trained up on this stuff, you might want to check him out. And then also to kind of plug the local schools, I would recommend checking out your community colleges or the local college. So again, this webcast, I'm just going to show you how to use the tools, but to actually apply the standard, you will want to check out some actual training on the subject. Okay, for GD&T, the elements, datums. Datums are basically imaginary, perfect reference planes on the part. They should be repeatable from part to part. And as you see on my graphic here, you can see that the part, and I'm talking about the one in the upper right here, that the part is somewhat wavy because at some point when you zoom in on a part under a microscope, you're going to see those imperfections. So these datums, you typically reference 3 points to set it up, should be repeatable from part to part. And again, when you get into GD&T, you start to realize that it's actually allowing more imperfection than hard numbers. So here's just an example of a couple of different parts and the datums that they've chosen to set it up. So here on the lower left, you see the part with the primary datum, the secondary, and the tertiary, and this is how they would look on the drawing. Typically on the drawing, what you'll see are these symbols indicating the type of tolerance, the characteristic, and the geometry controlled by that feature frame. The tool in SOLIDWORKS to do this, of course, if you're on a drawing, you've probably seen the annotation for adding a GD&T symbol. However, there is another tool called the DimXpert, and I want to go ahead and launch a poll here to see how many of you have actually used that and share the results. All right, it looks like a majority of you have not used it yet, and that's kind of why you're here. So that's excellent. Okay, so using DimXpert, first thing that we need to determine is what part type we're going to be applying this to. Whether it's a prismatic part, this would be things like plates, square parts, or whether your part is a turned part, this would typically be a part that you'd make on a lathe. And then we specify what tolerance type we want to control with the DimXpert, whether it's plus or minus tolerance or a geometric tolerance. Again, the primary difference between the two, a plus-minus tolerance is going to give you a square tolerance zone. Geometric tolerance typically gives you a round tolerance zone. And with that, I'm going to take us over to SOLIDWORKS to share this. Okay, so on this part here, to access the DimXpert, you'll notice this position symbol on the feature tree. When you click to access it, there's a couple different buttons here. There's the auto dimension scheme, which, by the way, I would also point out the DimXpert tab on your toolbar. Okay, and we're going to do the auto dimension. And the way that this works, it's asking us what type of part we're dealing with here. And as you can see, this is a plate. So this is going to be a prismatic part. Then I get to specify what type of tolerance I want to apply here, whether it's plus or minus or geometric. I'll do plus and minus first. Which, by the way, I would point out that relative to this particular part, you'll see that it's a regular SOLIDWORKS part. In other words, it's not an imported body. But this DimXpert is going to treat it like it's an imported body. So the model is just pure geometry to DimXpert. So in Essentials, we hammer very much, planning out your datum structure and modeling from it to get usable dimensions in your drawing. Well, here's kind of the next way to handle this, and that is to use DimXpert to set up your datums and get the dimensions for your drawing. And when we get over there, I'll share that. But that's just kind of give you an insight to what DimXpert is doing. It's ignoring all the features in the tree and just treating it as geometry. And now I'm going to go ahead and set up my datums. So my primary datum could be that face there. My secondary datum, I may want to choose the bottom here. And for my tertiary datum, I'm going to pick this corner over here. By the way, if I wanted to specify the middle of this part, I could also set up a width feature. That would allow me to pick two faces to specify the datum. But for this particular item, I'm just going to select the three planar faces. And for the scope here, since this is an auto dimension tool, I'm telling SOLIDWORKS that it's okay to go ahead and try to recognize all these features. And with that, I'll go ahead and specify OK. Now SOLIDWORKS goes ahead, and based on those datums, it gives me these dimensions. They're kind of scrunched up here, so let me go ahead and pull a few of them out. And you'll notice that my part changed color. It's now green. Okay, that's actually the tolerance status on this part. It states that everything or every face has been given a size and or location. And that's this tool right up here. Okay, the show tolerance status, the eyeglasses. If I turn it off, then it returns to my part color. But when I turn it on, it shows me that all these features have been identified. After all, you might not always be using the auto dimension scheme. You could, specify location or size dimensions on a particular feature. And on my next part here, I'm going to go and do another auto dimension. And this particular part is going to be a turned part. I'm going to go ahead and specify a geometric part this time. And for my datums, my primary datum, I'm going to go ahead and choose the back face here. The secondary datum, I'm going to use the bore. And based on that, again, I'm going to tell SOLIDWORKS to go ahead and recognize all those features. And I'm going to go ahead and hit OK on that. And here you can see again, SOLIDWORKS is showing me that each face has been toleranced. And as it toleranced each one of these parts, I'm going to go ahead and tile these here. You'll notice that it threw up a default tolerance. And we're going to talk about those settings here. So back over to the slideshow here. Within the document properties, you'll find there's a DimXpert area. That DimXpert area allows me to set the default tolerance size and location for each DimXpert type. So again, because this is a document property setting, that means it could be different for each file. So if you plan on using this, I recommend opening your part templates and then setting up your tolerances in your default part template. That way when you go to roll this out, it'll already be set up. In fact, if you have different templates based on different materials, then you could set the tolerance for each material. The DimXpert features that are supported are holes, cones, this would be an angled hole with taper on it, countersinks, counterbores, and planes, slots, notch, boss, cylinders, width features, pockets, surfaces, chamfers, and of course fillets. So I'm going to go ahead and open another poll here. I want to find out how you guys are currently doing drawings. So how do you guys end up doing your drawings currently? Do you redimension the drawing with smart dimensions? Use imported model items like we hammer in Essentials class? Are you actually using DimXpert dimensions? Or don't even use drawings at all? The model is king. Share the results. So it looks like a majority of you are redimensioning the views using the smart dimension at the drawing. That's pretty typical despite our best efforts to talk about clean design intent for the part, because I realize that a lot of times you aren't the person that started the part, and you get parts from all over the place, and some of them aren't even SOLIDWORKS parts, therefore it's impossible to actually control how the part was modeled, and you just need to get changes done. So I can definitely sympathize with that. However, hopefully I'll show you something new that will alleviate that, because after all, the best case scenario is to import the model items. That allows you to go ahead and make changes from the drawing to impact the model, but that's only in a perfect world. Here, since we are redimensioning the part, well, we might as well take advantage of the DimXpert at the model level and then have it import those dimensions into the drawing. And I'll show you how we do that here. Okay, so the first thing that I wanted to mention here was the DimXpert Options. Okay, so for Tools Options under the Document Properties, you'll see that there are two method types. There is a block tolerance or a general tolerance, and these are typically governed by the standard you're using. In other words, here I'm using ANSI. Okay, so ANSI is typically block. General is an ISO setting. Okay, and you can set, general would be, tolerance, fine, medium, coarse, etc. Block tolerance, you get to specify your decimal values. Relative to size dimensions, okay, you could specify on diameters what your allowable tolerance zone will be. You could either have it symmetrical, that's plus or minus the same amount. Bilateral, you could specify the upper and the lower limit, or use a block tolerance. Location dimensions, same type of deal. You go in there and you set up all your defaults. Chain dimensions. Okay, typically tolerance stack up. You want to avoid chain dimensioning. Geometric tolerance. Whether you're applying maximum material condition to your features, i.e. the largest part or the heaviest part, that would be the smallest holes, the largest possible size on the part. and how to treat this, specify your chamfer controls, and finally the display options. And let me go ahead and open one more part here, the manual wedge. Now, this particular item has a few dimensions already thrown on there, and I'm going to go ahead and turn on my tolerance status to see how much of this has already been specified. And you can see that there's one face here that has not yet been given a size or location. So from here I can go ahead and specify maybe a location dimension, and I'm going to go and grab the bottom face here. And then when I go ahead and throw in my next feature here, you'll notice it defaults to wanting to do an angle, but I'm actually talking about this corner here. So I need to specify an intersect line. That allows me to pick two faces, and based on those two faces, it'll generate an intersection line right here. So when I hit OK, I get to pull off my dimension. Once I do that, I can check my tolerance status again, and that allows me to fully define this part. Again, when I'm doing this, I could specify manually locations and sizes. I could manually apply datums, specify what my datum callout is and what face it's going to be. In fact, you'll notice over here, if you tried using the smart dimension and dimension something, SOLIDWORKS is bringing up the DimXpert. So you might have accidentally done this when you were thinking you were in a sketch and you tried throwing in a dimension and it automatically brought up the DimXpert, and we're wondering why that dimension came in that color, which, by the way, when I added that extra dimension, DimXpert recognized that I've over-constrained the part. Okay, so when I go over to my tolerance status, it's showing me that that face is over-defined. Okay, so where this comes into play relative to your drawings is if I go ahead and open a drawing and I take a look at this drawing, this part. First off, you'll notice that FeatureWorks wants to recognize the features on this. I'm going to say no. That's because it is an imported part. Again, SOLIDWORKS DimXpert treats the part as geometry, not as individual features. You can see that DimXpert has already gone in there and fully defined the part as I check out the tolerance status. Over at my drawing, when I'm doing my drawing, when I click on a view over here on the left hand side, you'll find the import options. I can import annotations. Now, design annotations would be the inserted model items. Okay, that is how the model was generated. Since this particular item is an imported model, I can instead go ahead and use the DimXpert annotations. When I do that, you'll notice that it pulls in those DimXpert dimensions. And I can do that on all my views. Import DimXpert annotation. And then I might have them all from that view as well. Now, one advantage to doing this, again, it's not a model item, so I can't exactly double click on this and change the model from the drawing, but just like model items, I can use Shift to drag dimensions from view to view. So if I wanted this dimension on the top, I could hold Shift and drag that dimension and then relocate it. Okay. Now, this is a lot quicker than trying to redimension the part at the drawing level. If I can go and use DimXpert at the model level, then I can go ahead and take advantage of those dimensions here at the drawing, and then you just reorganize them like you would otherwise. So Shift drag will move dimensions from view to view. Control drag will copy a dimension from view to view. But again, as we talk about that with model items, if you're going to control drag a dimension from view to view, you want to make sure one of them is set to reference, because this will be double dimensioning, as you know. So I'll go ahead and delete that one out of there. Okay, or when you're just inserting a model for the first time, and I'll just go ahead and insert one of the ones that I have open, maybe the prismatic plate. Okay, you'll notice that I can bring in the annotations while I'm dropping in the view. Okay, DimXpert annotations, and then it'll populate those. Or again, when I do another one, if I use the drawing palette and I specify which part to bring in, here I also have the option to import annotations, the DimXpert annotations. This is actually going to be a lot more useful than the model items if you did not control the original drawing, because I can still specify my datum structure, I can fully define my part, and then have the ability to move dimensions from view to view using shift drag, and have some relationship between the drawing and the model. To modify any one of these, you just open the part, find the dimension you're interested in changing, and then specify the new tolerance. And then when you go back to the drawing, of course it updates over here. And with that, I want to see if there are any questions on this. Okay, as far as DimXpert, does it work with component models that they've inherited their geometry from a master model or parent model? You cannot access the direct model dimension in the drawing at the part level. In other words, does DimXpert recognize geometry for deriving its dimensions, or does it use the dimensions that define the component model? Basically, again, the DimXpert is treating it all as geometry, so regardless of where it came from, it's just going to redimension the model. Okay, so again, it's just treating it as geometry, regardless of where it came from. I hope that answers your question. If it does not, go ahead and add something else in there, Mike. Let's see here. Oh, you just answered my question. The DimXpert is independent. 10-4. Okay. Yeah, I know I'm a few seconds behind on the questions. I'm sorry about that. Let's see here. Is DimXpert available for assemblies? In fact, it's used in TolAnalyst Stackup, which we're going to show here in a minute. And how are the number of decimals controlled? Again, under the options for the document properties. Oh, I'm in the drawing. Need to go over to the part here. Okay, DimXpert, here are your decimal places. And then under here, you also get to specify what your tolerance settings are. All right, what is tolerance stackup analysis? Tolerance stackup analysis is the study of dimensions and tolerance schemes to find out if your parts are going to fit together, whether they will function properly, or if you'll need to redesign the parts. So in this particular example here, I've got 4 parts with a permissible gap. If everything was on the high side, would it still fit with inside of part 1? That's the general idea. So to kind of find out what you guys are currently doing on tolerance analysis, I'm going to open up another poll here. Okay, how do you currently perform tolerance stackup analysis? Maybe you don't currently do it. Guess, grind, weld, and hammer to make it fit. It's kind of one of my favorites there. By hand, or another method. Or a popular one is use the Excel spreadsheet. Or maybe some of you are actually using the TolAnalyst. Okay, looks like some of you are doing it by hand or with an Excel spreadsheet. A few of you are not doing it currently. And others, guess, grind, weld, and hammer to fit. Well, okay, that works too. Alrighty, so what is tolerance stackup analysis? Of course, it's a worst case analysis. That is, you take your dimensions at their high end and their low end within the range of the tolerance zones and see how they stack up. So here's just one example. You find out what the minimum area that you're concerned with, in this case the 153 plus or minus a quarter, and then you add all the other parts at their high side and see what happens to the gap. And it looks like, based on the tolerances set up here, that I could potentially have an interference. So this illustrates the need for tolerance stack-up analysis. Another method of doing tolerance stack-up analysis is the root sum of squares. This is a statistical analysis that assumes that the dimension will vary within a normal distribution zone centered about the nominal of the part. In this case, nominal assuming the middle of the tolerance range, stating that the parts will not always be at their high side or low side, but somewhere around the middle within a normal distribution zone. And here's an example of how this is done. And finally, worst case tolerance analysis is dependent on how the parts are actually assembled. In this example here, with my part 50 plus or minus 1, if my assembly was assembled this way and if all the parts were at their high side and all the parts were at the low side, then my tolerance zone would be the same. So the actual worst case maximum or worst case minimum is when some are at their minimum and others are at their maximum. So here it's incorrect to assume max worst case is when all the parts are at their largest or they're all at their smallest. So I'll continue forward by opening another poll. Okay, how many of you have access to SOLIDWORKS Premium? And I need to get it now. The reason that is even an option is the only way to perform TolAnalyst or a tolerance analysis is this is an add-in for the SOLIDWORKS Premium package. So if you plan on wanting to run analysis like what I'm about to show you, then you're going to need to have Premium in order to do that. Okay, looks like over half of you have Premium already. That's great. That means you'll be able to use this after the webcast, right? So a few of you do not have access to Premium, and some of you want to get it now. And that's good. You know, these are good tools to have at your disposal. So I'm going to go ahead and hide the results. Okay, so TolAnalyst is SOLIDWORKS' tool for performing tolerance stack-up analysis on parts and assemblies. A single part analysis can be done by creating a single part assembly. The main features of TolAnalyst are the DimXpert dimensions are used to drive the analysis, and the analysis results include both worst case and root sum of squares statistical analysis. And with that, let's go into SOLIDWORKS to share this. All right, so I'll go ahead and open this base plate here. And I'm going to go ahead and add some dimensions to it. So through Auto Scheme, this particular item is a prismatic part. I want to use my geometric tolerance. My primary datum is going to be this face here. My secondary datum, I'm going to create a width feature. So to show you how to do that, as I click on one face, I then specify width and then pick the other face there. That will essentially put the datum in the middle here. And for my tertiary datum, I'll pick that face there. By the way, if you do have two faces that you want to create a compound plane or datum across multiple faces, with Create Compound Plane you can do that. And here I'll just go ahead and let Auto select all the features here. And you can see that it did in fact dimension everything for me. And I need to do that to my two other parts, the end plate. I'm going to go ahead and set up this one here. Again, it's a prismatic part. I'm using geometric tolerance, my primary datum. By the way, when you're setting up your datums, you want to think about how the assembly is, and maybe I should open that really quick to show you what this particular assembly looks like. Okay, so I did select this face as my primary datum for the base plate, and when I go to specify the tolerances on this end plate, I'm going to match the primary datums between those two parts. And then on this brace, I'll do the same thing. I'll match the primary datums between those two parts there. So as I go over to this part here, and I set up my dimension scheme, again, prismatic, geometric, my primary datum is going to be that bottom face there. My secondary datum, I'm going to create another width feature. So I'm going to grab the back side there and the front face there. And for my tertiary datum, I'm going to go and select one side. Again, I'm going to do all features, and SOLIDWORKS throws a dimension on everything. And then finally on the brace, this bottom face here, that's going to be my primary datum. My secondary datum, since this face is up against the other part, I'm going to go ahead and choose that as my secondary datum. And my tertiary datum, I'm going to go ahead and select width feature. So select other on that with width, and that will center it based on that brace. And again, my tolerance status tells me that everything has been given a dimension and is fully defined. And by the way, some of these parts are imported parts, others are actual parts modeled within SOLIDWORKS. So as I go to my assembly here, all these pieces have DimXpert dimensions applied to them, and so now I need to go to my add-ins, and then underneath the premium add-ins you'll notice your TolAnalyst. And then you can see the TolAnalyst in the assembly here. And now when I perform a study, I then tell SOLIDWORKS what I'm concerned with. In other words, which area I'm looking to capture. And in this particular example, I'm interested in this area here. And when I'm specifying what dimension I'm concerned with, I could specify which direction of measurement. I could even specify exact points. When I hit next, here's looking for the base part, which in this case is that one. Then it wants me to select the parts in their assembly order. So after I have the base plate, I'll probably put that part on there, and then probably that part, and then the braces, that one there, and then that one there. Next, SOLIDWORKS is going to ask me to prioritize which constraints I'm most concerned with first. Now, when I was doing this, I was concerned about matching all my primary datums, so I probably want to maintain that, and in this case, that would be that one there. And then maybe of secondary concern would be against the back face there. I go to the other end plate, do the same thing, and so forth, do the braces. Concerned with that first, that secondary, and then finish out on the last part. Alright, when I do that, should have left that open. Okay, with edit feature, here SOLIDWORKS has run the analysis based on everything that I've done here. Let me expand this a little bit so we can see it. The nominal on this is 20, because that's what we originally measured. The minimum on this is going to be 19. The maximum is going to be 21. And that's based on worst case scenario. Root sum of squares average, or statistical stackup, says I'm actually going to be 19.3, or maximum of 20.7. And if I specified what to display, currently it's displaying the maximum. If I specified minimum, it'll show me the minimum gap there versus maximum. And by the way, you'll notice that it's telling me the largest contributors. In this particular item, it looks like this dimension on the brace is what's controlling everything. Okay, and I do have another example that I'm going to share with you that has more contributors than just the one. But additional things that we can do here is we could specify whether or not to take into account orientation tolerances. And you can see when we do that, it does change what happens with our analysis. And I have some new contributors. Okay. So like the perpendicularity of that face all of a sudden got worse because now all of a sudden we're worried about that. Let me take us back over to the slideshow. Okay, so here orientation tolerances can be considered. Worst case with orientation tolerances disabled versus worst case when they are enabled. And you can see what that did to our analysis. It made it worse. And then as I mentioned, the contributor list, I can find out what is causing or the largest contributor to the amount of tolerance I have. After all, it might be easier to tighten up one dimension rather than many. And again, based on the contributors list, I can find out the largest contributor and then just modify that one dimension. From a manufacturing standpoint, that of course will be cheaper to tighten up one dimension rather than 5 others to attain the same result. And I'm going to go back into SOLIDWORKS and share the last assembly that I have. Alright, the last assembly that I have here, I have a caster. And each one of these parts has already been given their DimXpert dimensions. So as I open that, I'll just show you that this particular one has been set up with the datums and has the DimXpert dimensions on them. And a best practice when doing this is you may want to set up a configuration simplified for the analysis. So as I double click to switch configurations here, you'll notice that I hid the parts that are not going to be involved in this analysis. And maybe the first thing I'm interested in is how wide or how big this gap will be for the wheel. So under my DimXpert here, and I'll go ahead and pull this all the way up, I'm going to go ahead and tell SOLIDWORKS what dimension I'm interested in. Those two there. And just like before, I specify the base part and then the order that it's assembled. So those 2 supports and the 2 bushings. And as I walk through the next item here, I specify the constraints that I'm most concerned with. And in this particular item, I want to take a look at the interface face, or where this is setting on top of the base part. And then the holes would be my secondary concern. So again, axle support. There it is. That, and then the holes would be the second locating feature. And then the next axle support, same deal. It is nice that it does highlight to show you what faces it's talking about. So simple hole number 2. Okay, and then the bushings. That plane will locate it first. And then same deal there. You do need to make sure that it's selected over here and then specify. And based on that, here my nominal is 40, my minimum will be 38.3, maximum will be 41.7. Again, I could take into account the orientation tolerances, and it makes my results worse. Okay, and when you're done, oh, by the way, you can export these results as an Excel worksheet. And then if I want to run one more study, maybe I'm interested in bore to bore what my axle is going to wind up doing or needing to be. So as I go ahead and specify those two centers, I could then tell SOLIDWORKS that I want to control this in the Y direction relative to the triad here. Okay. And then same deal, pick the base part and then the order that they're assembled. And then specify the constraints. Again, I'm just trying to find the same ones that I had before. Make sure it's specified there. Bushing. Plane to locate it. And then the last bushing. Same deal. Okay, here axially looks like 1.1 will be the range that this thing varies. Okay, so that's probably not very good for what I want to do here. So in order to tighten this up, I can take a look at my contributors list, and from here I can go ahead and modify that tolerance. Currently it's 0.5 millimeter. If I tighten that up to maybe 0.25 and then recalculate. Okay, that helped on the one side, but I should do that to the other one as well. And then recalculate again. Now I'm at 0.6. Okay, so again, this contributors list allow you to tighten up certain areas of the tolerance to bring your parts closer to what they need to be for design without having to tighten everything else up. And again, as you can see here, I have multiple studies on the same assembly, and at any time I can go to edit feature on each study to see where it's at, and then of course modify any tolerance within the contributor list, and then that will update on the part. So again, in order to use this, you need to specify the DimXpert at the parts, and then at the assembly, through the add-ins for SOLIDWORKS Premium, you can turn on TolAnalyst, set up what your base part is, and then tell SOLIDWORKS what area you're concerned with, and then it gives you a contributors list as to why the tolerance is what it is. And with that, I'll bring us back over to the slideshow. Come on over and check us out at our Twitter page, our Facebook page, on YouTube, or our podcast website, solidworksherd.com, or check out our microblog site at herd.solidworksherd.com. Thanks again for joining me on yet another productivity webcast. Please check out this and other webcasts on our primary archive site. It's going to be webcasts.ddicad.com. I'm your host, Joseph Richter. Thank you.